So here we are in our last project for my Computational Research Methods course. This project is going to be about finite differences. This is based on a video series that's going on right now on this channel, so this video should go up kind of in the middle of that series. So I've gone ahead and made a little outline of the learning objectives and the code that they'll be using. The first learning objective that I want them to accomplish is to select an initial guess for the function. So just as a reminder, the way finite differences and successive over relaxation works is that you guess an initial shape for the function. Your guess is going to be wrong, and that's okay. You set up a bunch of lists to keep track of things, and then you put the guess into this loop. And basically with each iteration of this loop, the guess is going to get progressively better until there's no longer a significant change in the results. And so before my students get to the difference equation, before they get to all the technical stuff, I want them to make a guess of the function, their initial guess. So let's see here. The way we'll do this is in class, you have been given a differential equation with a pair of boundary conditions. Solving this differential equation requires the use of finite differences and successive over relaxation. And why don't we give these some acronyms just in case I need to refer to them significantly later. And now that I'm thinking about it, I wonder if I should call this a finite differences and successive over relaxation project. Which means I need to change the file name, Control-C to copy. Let's edit this, and successive over relaxation. There we go, rename. That way it's just, that way they have everything up front that they're expected to work with. Also, that way when they go to the videos, they know to go to the one that's about successive over relaxation. Before we get into the solution method, you need to determine an initial guess for the for the function that solves this differential equation. Your solution will likely be wrong, and that's okay. Let's make a little edit here. Your guess will likely be incorrect, and that's okay. The important feature is that the guess meets or comes close to meeting the boundary conditions. In this cell, describe your identify your initial guess, but we say use/LaTeX, because I'll have used a little bit of LaTeX at that point, hopefully. To identify your initial guess, you can use the equation below as a template. As a templemate, no, a template. Let's see, so let's put in a $sign here, and let's try to give them everything they might need for an equation, for a function in LaTeX. Actually, it's not an equation, it's a function. I've been seeing a lot of folks on Twitter making distinctions between functions and equations, and I'm trying to be compliant with that. So let's say f of x equals, I don't want to give them one that will work necessarily, so why don't we try slash cosine of x to the open brace square, close parentheses, minus, let's do a fraction here, fraction of x over 3. That's probably not going to be a workable solution, but it shows them kind of how to call out a function name and then how to use a fraction and how to use an exponent. I'm not sure that they need much more than that. All right, Control Enter. Oops, it doesn't recognize LaTeX. Oh, right, because I didn't capitalize the X. There we go. That's case sensitive. Okay, in class you have been given a differential equation with a pair of boundary conditions. Solving this differential equation requires the use of finite differences and successive over relaxation. Before we get into the solution method, you need to determine an initial guess for the function that solves this differential equation. Your guess will likely be incorrect, and that's okay. The important feature is that the guess meets or comes close to meeting the boundary conditions that you were given in class. And I think the way I might do it as I'm thinking about this, I think I might give, because I have 4 students in the class now, 4 students. I think what I might do is give out 2 differential equations and 2 sets of boundary conditions. And basically each student gets a different combination, so that if I'm student A, student B and C will have one of the same 2 things that I do. So each student will have 2 students who have one of the same items. One will have the same boundary conditions as me, and one will have the same differential equation as me. Okay, I think that's a good way to do that. In this cell, use LaTeX to identify your initial guess. You can use the function below as a template. Also, describe why you chose this function as your initial guess. And hopefully by now they know to replace the markdown, the text in this markdown cell to give that description, to give those answers. All right, learning objective 2, implement your initial guess and boundary conditions in a code. Do I want to? Yeah, I think I'll have the instructions here separately. In the code cell below, enter the function for your initial guess and your boundary conditions. I think that's pretty straightforward, because here in the code I have defined guess of x, guess equals your guess here, and then here we'll have leftmost value of x, your left boundary condition here, and then we'll have your right boundary condition here. And I think, do I want them going out from -10 to 10? Let's leave that for now. I'll decide later if I want to change that when I actually pick out the functions. So that is a 0 for default. Actually, no, I might want to give them 0, so let's change this to a 7 and this to a -3. There we go, just so they all have to change something. And then they shouldn't have to change the rest of this, because the rest of this is just creating the list for the results. All right, we come down to learning objective number 3. Transform a differential equation into a difference equation. All right, this is where we get into the nitty-gritty. Using the examples shown in class, and there's the video that this is based on, the video I got this code from. Use the examples shown in class and there. Transform your differential equation into a difference equation. Recall that this process involves using the recipes, and then here we'll have a reminder of how this works. So I'm going to do some LaTeX here. So I have df dx. Should I bother writing these as partials? It's just a function of one variable. I think I'll leave it as just a regular derivative for now. Df dx equals, and now I need to have a frac. Let's see, you need f on the right side, f of I plus 1. I am using an index I, right? Yeah, down here I use an index I, okay. Frac I, f to the right of it, minus, copy, paste, f to the left of it, current point, divide by h squared. And then I need to have one for the second derivative, copy, paste. So let's have the second derivative, d squared f dx squared. So here I keep these 2, but I leave this one as a plus sign, a little space in the middle, and then it's minus 2 times f at the current point. So the current point doesn't show up in the first derivative, but it does show up in the second derivative. And, oh, excuse me, this is the part that needs to be h squared. This part needs to be 2h. I would have gotten that when I checked my units. I'm sure my students would have found that. And then we need to have, and actually, you know what? I'm not comfortable with these being equal signs. Let's make them right arrows. Right arrow, because it becomes that. It's replaced by that. It's not actually equal to that. And then we'll have f right arrow becomes f underscore I. And x right arrow becomes x underscore I. I'll enter and make sure I got all that correctly. Okay, it did get correctly, but I wanted those on their own lines. Forgot whether that would respect the character turn or whether I need an extra one. And actually, let's replace these here. Just to put them in kind of an order in which they're building. Using the recipes there. Let's see. Well, will this put them center? Okay, it doesn't put them center. That's fine. Oh yeah, that would be begin equation. That's fine. Where each xi on a grid is separated by a distance h. Let's call that the step size. Size h. So this is also kind of filling in the place of a textbook that I'm not using. Let's see here. Oh yeah, I can say this is equal to f of x underscore I. Actually, let's do it this way because I'm not wanting them to replace with that. I'm wanting them to replace with fi, which is f of xi. So x gets replaced by xi, where each xi on a grid is separated by a step size h. F gets replaced by fi, which is f of xi. df dx becomes fi plus 1 minus fi minus 1 over 2h. d squared f dx squared becomes the point to the right minus 2 times the current point plus the point to the left divided by h squared. Okay. All right, did I say in this markdown cell earlier? Okay, yeah, I just said in this cell. All right, in this cell, show your work for transforming your differential equation into a difference equation. Then show your work for solving your difference equation for, you always want to solve it for the current value f underscore I. There we go. Does that need to be a separate learning objective, solving it for fi? I kind of feel like it does, because those are 2 steps, and the more steps we have, the more broken it is for students. Okay. So let's see, Control X, paste. Let's see here. This is going to be learning objective 4. Oops, this is not a code cell. Not supposed to be a code cell. Learning objective 4. Solve your difference equation for, let's be a little bit, let's work toward the goal here a little bit better. Rearrange your difference equation to provide an iterative solution. So now we say in this cell, show your work for solving your difference equation. Let's see here. In this cell, solve your difference equation for fi. So here I'm explicitly saying you need to transform it and then you need to show your work. And here I'm just saying solve your difference equation for fi. So I'm expecting them to understand that that means show your work and understand that it means use LaTeX. So even though I've got more learning objectives here than I had in my last couple of projects, and the instructions are a little bit longer, it's a bigger topic. Finite differences is a much bigger topic than anything we've done before, and so it's nice to be kind of scaffolding them toward that right now. All right, so this one becomes learning objective 5. Implement your difference equation in a code using successive over relaxation. In the code cell below, I think they usually capitalize code there since it's capitalized in the menu up here. In the code cell below, enter your solution. Actually, let's see here. What did I call it? An iterative solution. Your iterative solution. So I guess you don't really put the difference equation in there. You put your iterative solution in there. So I need to make sure to call it that here and in class. This is the result is your iterative solution that you will use in the code for this project. Okay. In the code cell below, enter your iterative solution for copy, paste. All right, here we go. Your iterative solution here. And let's provide just a little bit of recap. Recall that you should use the list f underscore what will be your f underscore list. There we go. Because you to reference function values, or reference values of the function f. In the code cell below, enter your iterative solution for fi. Recall that you should use flist to reference values of the function f. Okay, cool. Okay, so here we have the code that they'll be using. And so the only thing they need to change is their iterative solution here. Learning objective 6. Evaluate the results of your implementation of finite differences and SOR. Run both code cells above. Address any errors that arise. I'll put that in just in case. Address any errors that arise. In this cell, discuss. Oh goodness, I cannot spell today. Discuss the results of your code, including the final graph that it produces and the final graph that it produces, the number of iterations. Do I have it printing iterations? I do. Okay. Required for it to reach this final graph, and the graphs it produces along the way. I don't want them like grabbing screenshots of it. I think that ought to be fine to just say this. And the number of iterations required to produce, and the number of iterations required for it to reach this final graph. Are you satisfied with the accuracy of this final graph? Why or why not? If not, change the step size and or the let's see here, maximum acceptable change between guesses. Maximum acceptable change between guesses until you arrive at a final graph with which you are satisfied. Cool. And I don't tell them their criteria for being satisfied. They should have an intuitive sense for that by now. All right, so one last review here. Select an initial guess for the function. In class, you may give a differential equation with a pair of boundary conditions. Solving this differential equation requires the use of finite differences and successive over relaxation. Before we get into the solution method, you need to determine an initial guess for the function that solves this differential equation. Your guess will likely be incorrect, and that's okay. The important feature is that the guess meets or comes close to meeting the boundary conditions that you were given in class. In this cell, use LaTeX to identify your initial guess. You can use the function below as a template. Tempmate. I cannot spell today. Template. f of x equals cosine x squared minus x over 3. Also describe why you chose this function as your initial guess. Why you chose. Let's say how you chose. How and why you chose your initial guess. There we go. Learning objective 2. Implement your initial guess and boundary conditions in a code. In the code cell below, enter the function for your initial guess and your boundary conditions. Learning objective 3. Transform a differential equation into a difference equation. Using the example shown in class and there, transform your differential equation into a difference equation. Recall that this process involves using the recipes that and that in this cell. Show your work for transforming a difference equation into a difference equation. Learning objective 4. Rearrange your difference equation to provide an iterative solution. In this cell, Solve your difference equation for fi. The result is your iterative solution that you will use in the code for this project. Learning objective 5. Implement your iterative solution in a code using successive over relaxation. I guess I can just call it SOR there. Cool. In the code sub below, enter your iterative solution for fi. Recall that you should use the list flist to reference values of the function f. That's just when you have an f, put in an f underscore list of I, or I minus 1, or I plus 1, or whatever you've got. Finally, learning objective 6. Evaluate the results for implementation of FD and SOR. Run both code cells above. Address any errors that arise. In this cell, discuss the results of your code, including the final graph that it produces and the number of iterations required for it to reach this final graph. Are you satisfied with the accuracy of this final graph? Why or why not? If not, change the step size and or the maximum acceptable change between guesses until you arrive at a final graph with which you are satisfied. Alright, well, I have arrived at a final project with which I am satisfied. As always, please let me know of any feedback you have in the comments below. I am currently planning to next week release a video in which I go over your comments and make changes to these assignments. Unless, of course, I don't get any comments. I've had a couple videos up. I don't have any comments yet. So please make a few so that I can have that conversation with you. If not, I'll go ahead and move on to my next series. But then at the end of the semester, at the end of the fall term, I want to come back to this series and present a reflection on these projects and how they went, what I had to change about them, how the students responded to them. So I think that'll be a nice way to cap this off. So as always, thank you so much for watching. I will see you next time. Bye-bye.